Okay, class, picking up where we left off at, I was saying at the end of the last video that I will use completing the square last only if directed because that takes a long time and could get quite messy. It says solve using the most efficient method. Now the first thing here, let's get all of these values on the left hand side to make this equal 0. So we would add 2d and subtract 35 on both sides. So we have x squared plus 2d minus 35 is equal to 0. Now there's one little glitch here. This d should be an x, so it should be x squared minus 2x minus 35 equals 0. So if you have d in your course pack, you could cross it out and put an x in its place. So it's x squared plus 2x minus 35 equals 0. And we could use the factoring method, which will leave us x plus 7 times x minus 5 equals 0. And we'll set x plus 7 equals 0 and x minus 5 equals 0. And that will give us x is negative 7. Also, x is 5. So we could just say x is negative 7 or x equals 5. And that would be our final answer. Now we come here to b. Now if you notice here, I think using a square root method would be easier because all we would have to do is add 1 to both sides and then divide both sides by 2. We have x minus 2 in parentheses squared equals, should be 8, not 18, equals 8. And then we would take the square root of both sides. And this will give us x minus 2 is equal to positive or negative square root of 8. Now we will add 2 on both sides. And we will have x is equal to 2 plus or minus. Now we know there's a perfect square in 8. So we'll do square root of 4 times square root of 2. And our final answer will be x is equal to 2 plus or minus 2 square root 2. Now, there's a lot of 2's. So this is our final answer for this problem. So that's A and B. Now we want to go here to C and D. Now if you look here at C, C is not easy to factor. So myself, I think I would use the quadratic formula. So we need to list our A, B, and C. This equation is already set up equal to 0. So our A here would be 1, our B would be 1, and our C is 3. So we have x is equal to, we know it's negative, and then B, plus or minus the square root of B squared, minus 4. We know A is 1, and C is 3. And this is all over 2 times A is 1. So we have x is equal to negative 1 plus or minus the square root of 1. Negative 4 times 1 is negative 4 times 3. Will give you a minus 12 all over 2. So we have x equals negative 1 plus or minus the square root of negative 11 all over 2. Now we know the square root of negative 11, there's no perfect square in 11, so we'll just pull the I out. So it'll be x is equal to negative 1 plus or minus I square root of 11 all over 2. And that is the final answer for this problem. Now we come to D. Now this also, I believe that I will use the quadratic formula because it's set up in the form and it doesn't take that long to put this in a quadratic formula. So we have x is equal to, now we know our A is 4, should have listed that first, B is 3, and C is negative 2. So we have the opposite of 3 plus or minus the square root of 3 squared minus 4. Our A is 4, and our C is negative 2. And that's all over 2 times 4. So we had x is equal to -3 plus or minus the square root of 3 squared is 9. So we got a -4 times 4 is a -16 times a -2, which would give us a positive 32. All over 2 times 4 is 8. So we have x is equal to -3 plus or minus the square root of 41 all over 8. Now 41 does not have a perfect square in it, so this is the end of this problem. Now we come to example 3. The current through, okay, your example 3 looks a little different than my example 3. Our equation is the same, our A is the same, but the directions for example 3 are different. So I'm going to use the directions that you have in your course pack, which states the amount of electricity flowing through a surface is called the current I, and it's measured in amperes, A. The current through a particular wire, I of t, in amperes after t seconds could be modeled by, and we have this formula here. Okay, class, I just took the liberty of changing this so it will look more like the example you have in your course pack with the same language here. Okay, so we have this formula. It says find t when I of t is equal to 10 by hand. Give 2 decimal places. What does it mean in this situation? So if I of t is equal to 10, we would take this formula and we would change I of t to 10. So 10 is equal to 2t squared minus 6t plus 7. Now, we can subtract 10 on both sides. And we will have 0 is equal to 2t squared minus 6t minus 3. Now we can list our A, B, and C. A is 2, B is -6, and C is -3. So now we will have t, which represents our x, is equal to, now we know we will still have -b plus or minus the square root of b squared minus 4ac all over 2a. Now we will substitute in these values. So we had t is equal to the opposite of -6 plus or minus the square root of -6 squared minus 4 times a is 2 and c is -3 all over 2 times 2. So the opposite of 6 is 6 plus or minus the square root of 36. -4 times 2 is -8 times a -3 is a positive 24 all over 4. So now we will have t is equal to 6 plus or minus the square root of 60 all over 4. Now we're going to put this in our calculator so you can solve this. So you would put in your calculator and I'll just write this out for you. In your calculator you will have, one instance you will have 6 plus the square root of 60 all over 4. And you will also have 6 minus the square root of 60 all over 4 that you will put in your calculator. Now, when you put these values in your calculator, I'm going to put their values up here. One of your values would be t is approximately a -0.44. And another one of your values would be t is approximately 3.44. Now we know as far as time is concerned, unless we're planning on traveling back in time, we're not going to get a -0.44. So our t, because this would be impossible in this situation, so our t is approximately 3.44. So we will put there are 10 amps of electrical current flowing through the wire at about 3.44 seconds. And that is our final answer. Okay, now we go to the last problem here. So we go here to B. It says verify the answer above using your calculator. Include a sketch of the graph. Now, when we include this sketch of the graph here, we know we will go from 0 to 15 and from 0 to 20 here. Now, we will draw a sketch based upon our calculator, and we will have 3.436, comma 10, which is approximately 3.44 in the 10 amps. So 3.44 seconds or 3.436 seconds will produce 10 amps, which is basically what we already have. So this is a sketch of the graph, and this is our final answer for section 7.5.